Hello and welcome to Math with Beth. Okay, I'm working on that. We are going to get started with factoring. There is a lot to factoring, but we're just going to start with step one of factoring, which is taking out or dividing out the GCF, the greatest common factor. So when looking at something like this is a binomial because it has two terms. So is this one, but something like this has three terms. Just so you know what I'm talking about when I say the terms. So what you do is you look at all of the terms and you decide what do they have in common. So you can tell from this first problem that as far as x's go, I cannot take out an x because they don't both have it. They don't have that in common. So I'm not going to touch the x, but for the numbers, 3 and 9 have something in common. They have a common factor. They can both be divided by 3. So that is what I'm going to take out. So remember, taking out means divide. So if I had 3x and I divided it by 3, what would I have left? So if you need to go off to the side and actually write that, you can. 3x divided by 3, the 3 would be gone. And so all you would have is x. Now if I take the 9, or you can think of it as a -9, and divide that by 3, I would have -3. So hopefully you won't have to do this all the time, but if you're new to this and you want to do that, that's totally fine. But really, this is all just side work. This is the factoring, and this is your final answer. You can check to see if you did it right by doing the opposite. So instead of dividing, multiply. If you multiply this 3, which means distribute this 3 back, wouldn't you get 3x minus 9? Yes. So I must have done that correctly. For the second one, I can see that again, they do not have the x in common. I can divide these both by 4, but just to kind of get you prepared for some of the harder problems that come later, if there's a negative in front, I usually bring that out also. So I am going to take out or divide out a -4. So be careful. A negative divided by a negative is a positive. The 4s would be gone. So that would just be an x. So that's similar to the first one, except it was just a negative I was taking out. So I really just did this. And now I'm going to do this. So a +16 divided by a -4 is -4. Again, you can distribute and see if that works. Now I have an example with 3 terms. So now I need to make sure whatever I decide to take out actually works for all 3. So my first term has x squared, which is 2x's, basically an x and another x. I have an x here, but I have no x with the 30, so I can't take an x out again. 3, -6, and 30 have 3 in common, so I'm going to take out or divide out the 3. So this is what I'm basically going to do to decide what would be left in this parenthesis. If you start with 3 terms, you should have 3 terms in your parenthesis when you're done. So taking out a 3 leaves me with an x squared here, a -2x here, and a +10 here. There is possibly more that we could do here, but we are just doing step 1 today, taking out that greatest common factor. Next one, we finally have an example where we can take an x out. If this is an x squared, which is basically an x and another x, and here we have an x, they have that x in common. So I can take one x out, and I can also take the 4, and you'll usually see that written with the number in front of the letter. The letters are called variables. So I'm taking a 4x out of this problem. So again, if you need to see what you're doing instead of just doing it in your head, I'm technically dividing both of these by 4x. So in this case, the 4s would wipe out. They don't really wipe out, they become a 1. So that's really 1. And then x squared divided by x is x, because you basically just subtract with variables. Minus, here, the x's would wipe out to 1, and you would just have the 2. Again, the trickier these get, you really might want to do the distributing just to make sure you didn't miss anything or make a mistake. Okay, one more with 3 terms. This time there's a negative out front. So like I said, I would recommend taking that negative out. So just be careful because that means you're dividing by a negative. So the signs should change. As far as the x's, we have 4, 3, and then 2. So all of the terms do have an x. In fact, all of the terms have 2 x's. So I'm going to be taking out x squared. And then 6, 18, and 2, or you can think of it as -6, +18, and -2, they all have 2 in common, or -2. So I'm taking out -2x squared. So again, I should end up with 3 terms in my parentheses because I have 3 to start with, and I'm dividing each one of those by -2x squared. So -6x to the 4th divided by -2, x to the 2nd is a +3. And then again, you think subtract here. So 4 minus 2 leaves you with 2 x's. 18 divided by -2 is -9, and that would leave you with 1x once you take the 2 out. And then finally, be very careful here. A lot of people mess up here because they think, oh, -2x squared, I took all of that out. So it's just gone. That does not make sense because remember, if you started with 3 terms, you should still have 3 terms in your parenthesis. So remember that a -2x squared divided by a -2x squared is not 0. It's not gone. It's 1. So you need that +1 at the end. All right, you cannot learn math without doing math. So I really hope you'll take a second to pause the video and try these and then start it again and see how I did them. Number 1, I'm taking out a 4. That one's not too bad. Number 2, I'm going to take out a -5x. That would leave me with an x plus 3. For the next one, I need to be careful. I have 3 terms, so I only can take out what works for all 3. So I'm going to take out a 2 and an x. I better have 3 terms in here if I did it correctly. 2x to the 3rd divided by 2x would be 1. So you can write the 1 if you want to, but you don't have to because I have an x squared that would go with it. -6 divided by 2 is -3, and I would still have 1x left after taking 1 out. And 12 divided by 2 is +6. There was only an x, and I took out an x, so there should be no x with the 6. Number 4, I can take out a 9x to the 3rd. 2x squared minus, here's the tricky one again, I took everything out, so make sure you have that 1. In this case, it was a -1 because I had a negative divided by a positive. Last time it ended up being a +1 because I had a -2x squared divided by -2x squared. Okay, number 5. I have a lot more going on here, so I wanted to show you one of these. First, I have a negative in the front, so I'm going to take out a negative. Next, I'm going to look at my numbers. The most I could take out of 8 and 4 is 4. Now I'm going to do my x's and my y's separately. I have 3 x's here and 2 here. So the most I could take out would be 2. And then for the y's, I have 2 y's here, but 4 here. So again, the most I could take out is 2. What does that leave me with when I do that? -8 divided by -4 is +2. For the x's, I would still have 1, and for the y's, I wouldn't have any left there. Then +4 divided by -4 is -1. Again, you can write the 1, but you might not have to if there's going to be some variables. X squared, I took out x squared, so the x's are gone. Y to the 4th, taking out y to the 2nd would leave me with y to the 2nd. So that one was a little different. Finally, last one, I see a negative in the front, so I'm going to take out a negative. For the numbers, I can take out a 9, and for the x's, I could only take out 1. That would leave me with 3x minus 1. If you understand the factoring part, but you're a little confused how I'm deciding on the greatest common factor, especially if these numbers were to get a lot bigger, what if this was a 64 and this was a 130? Would you be able to figure out the greatest common factor? If not, check out my video on finding the greatest common factor. If you like this video, please like it and subscribe to my channel. Thank you.